Hi there, every creature. Lumit the Icelandic pony reporting for duty, with a slightly bent drawbar, a very mangled nut, and a whole lot of determination. I've gathered my magnificent band of raptor musicians, because before I fix anything today, I've got to sing about it. So flap your feathers, perk your ears, and get ready. This tune is all about my poor battered drawbar, the joy of making a new one, and how glorious life will be once the spindle behaves again.
My drawbar is rattling and clanking. Its threads are all bangled and torn. It slipped when the collet was tightened. A nightmare each time it was used. Bring back, oh bring back a drawbar to me, to me. Bring back the drawbar that is usable. I chucked up a bar in the lathe jaws and faced it to tidy the end. I turned it to size nice and even, then cut threads that proudly would bend. Turn back, the chips curled like ribbon and flew, Turn back, a smooth little drawbar I made. Now fitted inside Schaublin spindle, it holds every tool firm and tight. No wobble, no slipping, no drama. My machine runs through with delight. Clamp back, the collets all tighten with glee. Clamp back, my Schaublin now sings joyfully. Clamp back, the collets all tighten with glee. Clamp back, my Schaublin now sings joyfully.
Phew, that felt amazing. Nothing like a rousing tune with a pack of talented raptors to get the shop energy buzzing. Alright, song is sung. Spirits are high. And now it's time to roll up my sleeves, spin up the mill, and actually make this shiny new drawbar. Let's turn that musical inspiration into chips, precision, and a machine that runs better than ever.
So, here I'm soldering the carbide bit into this, well, it's a shank with a suitable slot for the carbide bit. And the first thing, well, I milled it and the angles here are correct, the flanks are suitably angled so that I can grind off things when the piece is finally soldered in there. And now we need stuff there. This is some flux, which is actually very murky stuff, suitable for your for your sausages, for example. And then it should be used quite liberally here, like that. And then I also need to put some into this workpiece, like that. And then this one goes here, quite simply. Yeah, that's okay. We have here some bits of this thing which is called, well, it's actually silver and cadmium and all those poisonous materials which you shouldn't breathe too much. But since I'm not doing this for my work, I can do this. Yeah. So as you can see, it's not very straight at the moment, but there you are. Then I have this kind of a hook which I'm using to hold the entire thing in place while I'm heating it. Because this will actually try to jump off here when it warms up, because that stuff contains water which boils, and then it tries to jump off. So now I will light up my torch, which is very simple propane torch. There you are. And now you have to be very careful where you point with this. You don't want to point it to any plastic things, etc. Not to your face or anything like that. And then I now start pushing this down and warm this. Okay, it already tried to move on me. I will warm it using the shank first. Okay. I think it is now already. I can leave it alone now there. Then we just wait. A little bit more. Like that. It starts to approach the melting temperature of the silver solder. Now it melts and it should flow there inside. I'm trying to put a little bit more there, like that. Okay, then here in the back side. Okay, there you are. Now we just, as you can see, it's actually already have gone around. I just heat a little bit here up and that's it. And now it's very important to let it cool down by itself. You don't put this into water. That might of course cool it down really quickly, but it also would make it so that the carbide tip would crack. It doesn't like the temperature change. It will crack immediately when you put it into water and, well, yeah. But now when we let it air cool there slowly and nicely, yeah, then it's okay. So, that's it. It's done.
You look at Wi-Fi to the right.
Yes, I do.
Times.
Yeah.
Yeah.
Yeah. You know, I had here, there, an inspector who is checking that this is safe to do. I don't know what she thinks about this, but I think it's quite safe. So I'm actually now grinding this threading tool to the correct dimensions, and as you can see there is a lot to grind off from this flank. And well, first things first, the tool itself is tilted 30 degrees and then the head is tilted this way 5 degrees. So we get a 5-degree relief angle with 30 degrees angle in that flank relief angle. So now, and I'm running this 500 revolutions per minute. And oh yeah, one more thing. This is this thing here, this one. This is boron nitrate. Well, it's something like that. Boron nitrate disc with flat surface there under, so it's really usable for this kind of grinding. And it's quite coarse. It's not fine, so it takes a lot of, in a way, in one pass. I can take 0.2 millimeters in one go always, so it progresses a little bit faster. And then I have mummified everything here around, because this dust is very abrasive. The boron nitrate doesn't wear off very rapidly, but this wolfram carbide hard metal will actually, and the dust is quite heavy, so it lands quickly into that paper here, so it's not that bad. It doesn't make dust, it makes, I don't know how to tell it, it makes heavy, very small particles. So now we go. Okay, that I haven't done that yet. So 0.1 millimeter speed, and then we go slowly. That's the first, and then another 0.2 millimeters. And I will continue doing this quite a long time now. Be clean now. Well, it's not entirely clean, but it's clean enough. Okay, done. Not too heavy, not too, well, it's a little bit tedious, this one. Just to show you, this black stuff here, that's actually very dangerous, and it's, well, it's unhealthy. You shouldn't get this stuff into your system, really, and then it's also abrasive. So if you mix that one with oil or coolant or something, you get a very good grinding paste. So therefore I'm always doing this type of things dry, so I avoid making grinding paste. So now I show you how to tram this milling machine accurately enough. So first we release these. There are 4 cap screws here which are holding this head. As you can see, it started to move like this. You can move it quite easily. And then we have here, unfortunately you cannot see it, but there is a locking pin. Now, there you are. It's locked in 90 degrees now. So just tighten now these. I wish I had a better tool for this. Maybe I should make one. Especially this here in the back is really hard to turn. Okay, now it's trammed. And then I put this in the center somewhere like that. And now next step I will mill the top face flat. Okay, there we go. Now I grind the top of this tool flat. I have here those small magnets that are keeping my mummification in place. Yeah, okay. So first things first, let's touch. That's near enough. And now let's touch. Okay. And now we progress in 0.2 millimeter steps. Yes, I think we are there. Yep. It's flat. Huh. Next thing will be the rake angle, which is 4 degrees. Okay, here we have a lever. When I push it here, it releases the lock of this cylinder. So now I can, if I pull this, oh, we have a loose thing here. Why? Okay, if I pull this one, we can move the head back and forth. Okay, but when I put it down there, I can actually tilt it. And now, because we are wanting not that way, but this way, and it should be something like 4 degrees, should be enough, like that. And now we have 4 degrees angle there. And now I pull this, and it's locked in place. Easy. And yeah, there is a scale here. And these are really, really accurate. Let's lower the table so that I can put the rake angle here. I don't need to use the whole width of the blade, only about here. And I think that's it. And now I need to lock my X. There you are. And then I just want to see whether I have enough trouble here. Yes, I do. And now the first thing is to touch. Again. Oh yeah, okay. it. With rake angle and everything. Well, there is one thing that needs to be done for this, and it's the tip. It has to be, you cannot leave it like that. It will break in no time. So, but that one I will do with a diamond file. This is, well, or maybe in my bench grinder where I also have a CBN wheel. This is, oh yeah, CBN, so carbon boron nitrate. So, yeah. So this is now ready. Well, actually the rake angle could be as much as 8 degrees. Well, I think 4 degrees is okay. So now, that's it. Well, okay, now to the main event. It will be the drawbar. This here is a sorry excuse of a drawbar. Yeah, it's functional. There is absolutely nothing wrong with it. It does the job, but this end, look carefully, what do you see here? Well, that corner, for example, and then all these edges are not very good, and so on. Yeah, okay. So what this is actually, it's a certain length. This part is something like 16 millimeters. This is M12, which is a problem. I will come back to that later on. And then we will, actually now this doesn't have it. I should have in there this kind of a thing inside, so that I can use the Allen wrench to screw it out. Now I need to use a special tool for this, and well, I don't like it. Okay. I said that I have a problem with this thread. Well, the intention was to use our new retracting tool holder to make this thread. There is one thing though, let me show you. So, the pitch, the pitch of the M12 thread is 1.5 millimeters. Let me show you. Well, as you can see, here is the table of different these. Here are inch imperial threads. These are metric threads, and this is, well, I don't know what this is. A millimeter per pi, whatever that is. But this one I always use. And now if you look this table here, there is 1.5 millimeters everywhere, anywhere. Well, can you find it? I couldn't, because there isn't. It doesn't have it. But here in the back, when we open this nice little door here, we can look at this table here. This table is for metric threads. And there you have it, 1.5 somewhere. Sorry, let's check this out, because M12, there, 1.75. Oh, wow, let's see if it is somewhere there. 1.75 is, this is also something I shouldn't have here, and I really don't have it. So we go back to here, and 1.75, is it there? Yes, it is, there. That's our thread pitch. But we need 1.75. We need 72 teeth gear here. We already have 21 here. I think I have the 28 teeth gear which was requested. So it needs 28 teeth gear. That one I have. This one I don't have. I have here, oh, it's very dark, but it's actually 84 teeth, this one. And so the configuration is like this now. This one should be then 28. That one I do have. That one should be 72, which I don't have. So, yeah, I should make a gear like that in order to be able to single point thread the correct pitch here. That's the problem. I don't, this episode would be too long, and and I don't think I have the material either. So we are going to use a die for that one. So going back to this one, we are going to use a die for that one. So we make this drawbar. But we made a really nice looking threading tool, which I really can use later on. It's like this. It's really nice. Yeah. Okay. So let's start digging this workpiece out of the material. This is the material, and it's something like, it's called mock. Probably the nearest substitute would be 4140 steel. And now I will measure this part here. How long do we need this? Says 51 millimeters here. Well, okay. Then I will put this into here and to the end of the, first I will, of course, this is loose. I want to have it really firmly in there. So there you are. Now it's tight, and now I can, and this is also, I always forget to tighten these. And let's see now. That's the one, and I zero my travel indicator here. You can measure lengths with this one quite exactly. So it was 51 millimeters. So 51. 1 millimeter for this to face, maybe, and then 2 millimeters for cutting it, parting off. So it will be 51 plus 3. So let's put a little bit more there, like 55 millimeters. There you are. That's 55. And now I just set up my this carriage stop. Goes like there. Yeah, it should be now there. And then the speed, at the moment 800 revolutions per minute. 800. Let's see how it looks. Well, maybe it's all right. And then the feed should be, now it's a very fine feed, and I will make it a little bit. It's 0.076 millimeters per revolution. So well, let's put one step back this speed down to 600. There you are. And now let's check that this is tight. Yeah. Everything is tight there. Then I touch here. And this is VNMG, which is my favorite tool for doing things like this. There you are. And actually, let's see which direction it is feeding. The direction is good. Let's zero this one. I take 1 millimeter away from the diameter now. Oh yeah, let's go. Let's see what happens here. Yeah, it's breaking the chips, which is really good. There you are. Let's go back here. And now I can measure it. Well, the goal here is the diameter, the largest diameter here, which is 36 millimeters. Really? Yes, really. 36 millimeters, and we are now at 39. So 3 millimeters to go off. And these are not very, how would I say, not very, so 3 millimeters. Okay, let's put it there. I will take 1 millimeter passes here now. And it probably could benefit. No, it doesn't benefit from anything. Maybe a harder feed, but let's go. Let's see. I will test it. No need to test. It is absolutely correct here now. Very nice chips, actually. Let's see. Let's see. What's the trouble with this one? First of all, it's not VNMG. And yeah, I'll change this to VNMG. It was something else. Ah, yeah. Here we have it. Hopefully we can reach. Yes, we can reach. 1 more millimeter. Let's see whether this is better. Yeah, a lot better. I will actually speed it up. Quite a lot, 1200, and then I will slow down the feed and take only 0.5 millimeter. Let's see what this does. So now it's 36.75. So we need to take away 0.75 millimeters. So if you divide that by 2, so you get 35 plus 37.5. So 10, 20, 30, 35, 37.5 here. And now that's I try to equalize the last 2 steps. There you go. Well, the chips went to the floor. Okay. And now, let's check this one. Oh yeah, and the surface finish is way better. Really way better. And now we can take the rest. This is the last pass. That's really good. Okay, let's go. Well, it's adequate and not too bad. Not a shiny mirror-like finish, no. It's a little bit coarse, but it's okay. And now, this is like 100 over. Let's see. It will be this part here, and the length of that part is approximately to the end. It will be 20. No, actually we should measure it from here. That is the place. It's quite exactly 40. So this place here, this place, that place is 40 millimeters from here. So that's the next we make. So hopefully, I think we don't reach in there enough. No, we don't. I think I still should use the other blade. Hopefully it doesn't break on me again. Probably the wrong height. Maybe. Maybe I should lower. Oh, no, it's not the wrong height either. So actually what I will do, I will put it a little bit this way. One step back. That's a good one. Yeah. Now I will zero this again here. And it should be 40 millimeters. There. I think I need to take only 0.5 millimeter cuts here. This probably doesn't tolerate more, this blade. Now I need to touch it really. Let's take first 1/2 millimeter and see what it does. Was this tight enough? Doesn't like me at all. I think this I need to index it because it's probably broken. Let's see what it does. First of all, you need to I think you need to, yes, you need to tighten the tool. And it's doing well, I know already, because it's not complaining even if the tool was loose. No. It doesn't like me. And what I noticed here, seems like our center is not in the center. It vibrates. I felt this vibrating. So maybe, let's see how it. Yeah, it's not even near the center. So I have one tool to correct it. Somewhere here. Oh, there you are. That's the one. We need to set the compound to 30 degrees. And then 30 degrees. So 30, there you are, that's the one. Ah, wrong. 2. Okay, so now I first need to put it in a suitable slot here. Is that a suitable slot? One more. I think that's the one. And then we need to rise it. It's not even near the correct tool height. Okay. I think that's it. Oh yeah. This is okay. And then we go. That's really bad. I should have corrected this before I started. Now we might have a little bit of a. There you are. Let's see how it looks like. Very good. Okay. It might be that we need to take something away from it. But let's see. Now let's take 1.5 millimeter here first. Measure it. Well, the surface isn't any better. It's as it was before. It didn't become any better, but now it's 13.61. Yeah, 13.61. So. Like that. After that it should be exactly 30. Let's see. So let's measure it. It should be quite exact millimeters now. It should. Well, and it's 100 over. Now it behaves as it should. It was really horrific. I don't know. Maybe the eccentricity caused some trouble for me. Okay. So now let's do the bitter end.
Parting off this now. Very simple thing to do. I hope it doesn't do any stupid things when it finally goes through. It's very near now. There you are. Huh. Yeah. Yeah, parted off. So this face here, I want it to be like in 90 degrees perfectly with the shank here. So now this is the reason why I face it. So let's see whether I already locked the carriage. No, I didn't. I want to lock it. And then let's do this. That's it. Oh wow, it's from a different planet. Okay, so it was the insert. Actually, it was somehow cracked. Sometimes you don't see it, even though it is cracked. And now, next step is to drill a 10mm hole all the way through. I start with a stub drill. The speed is a little bit too much, I believe. Let's go to 600. This is 10mm after all. Like there. And then let's hope it doesn't go. It did not. It tries to. I think we need to do something for that. It really isn't very good like that. And then the speed is again quite high. We need 1200 at least. Let's see now. This is really effective. Still, I need to. I think you are there now. Maybe a little bit more. Okay. That's it. And I will try to lock it a little bit so that it's more steady. Let's see now. Now it shouldn't. 10mm twist drill. And it should be all the way through. So here we start. Not here, here. Like that, and we are going to use some oil here. So let's go. We are through now. Finally. Yeah. So that was the 10mm hole all the way through, and now I let it cool. It's hot. Yeah, okay. So every time you put your drills into index, always clean them up. It's a good habit that will, well, it's hot. It's hot. Now this is a 15.25mm drill. I will push it through there to a depth of 22mm. Yeah, I have here a very small scale which I can use for that. And then we need to slow this even more down. So 400 might be too much. 300 about. Yep, that's okay. And away we go. 22mm. Let's see. Now it's 20, 21 and 22. There you are. That's it. Done. I'm knocking these in a little bit like this. Need to. And what this is an 15.75mm pre-reamer drill, and this should go all the way down. There is not much resistance in there. There you are, bottom it. Yep. And again, wipe the chips off from this. And here we have a 16H7 reamer. So what I'm trying to do here is to create an accurate straight hole. And this is the tool I'm using to get the drills off from that collet, one might say. And also this goes all the way down. Seems to be eating a lot. What is this? Is this really 16H7? Did I read it correctly?
I need to check it out one more time. 18! Okay. Oh, wow. Now this is 16. Did I do a lot of damage? Not too much. Okay. Man. You should learn how to read. That's now it should go. I was wondering why it produced such, but we can actually, there is 1 millimeter too much material there already, so I can live with that and still make it beautiful. Yeah, now it's like it should be. No resistance at all, or very little. There you are. And I think it's still enough for, yeah, it is. Ah, scheisse. Yeah. Okay. Well, now I just need to get rid of that extra. And now we need a lot more speed. 100, 1200. Yeah. I think that's okay now. Yeah. Right there. Let's see what happens here. There you are. Well, I could actually go in there quite a lot deeper. Like that. I think it's there now. Just make sure we have the room. This is just so that I don't hurt myself in it. I probably need to file it a little bit. And again, left hand, not in the right hand, left hand. Then it's safe to do this. Okay. There you are. Let's use this one though now. So I think it's that way, no, this way maybe. Let's see.
So this would be 9 millimeters after I have reached the edge. There you are. I have reached the edge. And now we go there, like that. Man. Aha! Now I don't know the depth. Huh. But yes, this is something why you should knock this in like that. And then I need to, this is now in 0. There is the place, I believe. Now let's do it again. It was something like 5, now it's 6, 7, 8, and 9. Let's see how it looks with this. This should go there like that. Oh yeah, it's actually very good. Yeah. Okay. Now just get it out from there. Yep. Okay. So I have attached my dividing head into the vise. Well, as you can see, this vise is very capable. You can do it as such. As well, the envelope of this milling machine. Because now, if you can see it, I have retracted the cylinder way back so that it's well inside the machine. So I have enough room here, actually quite a lot. And well, the next step is to touch the top surface. Let me bring you a little bit nearer, like that. And now, well, I'm running this again at 600 revolutions per minute. And I will touch the top surface first. There you are, it's touched. And now I will come back here. And now, well, let's see. The diameter of this one is 35 millimeters. And the flats should be, well, 27 millimeters apart. So 35 minus 27 is 8. So it will be 4 millimeters down. I will put a little bit more than 4, but just a hair. So now I need to draw it away from there, and 4. So that's 1.5. 3, and that's 4, and let's put 2, well, 1/10 in there.
here. Okay. And now I will touch the side of that. There you are. And now let's go back here. And now the depth is 6 millimeters. So that's 4, 5 and 6. There you are. And this is already 0 degrees. So now let's mill the first flat. Well, easy enough. And now I index it to 60 degrees. Oh, 60. Oh man. That was that's 0, that's 60. There is this pin which I can use here. That should be 60 now. Next flat, please. I'm feeding this manual. Then 120. $180. Then 240. And finally 320. 240. No. Yeah. That's not the one. 300, I mean, of course. That's the mistake I made previous time. Ah. Okay. We should have it there now. Not more complicated than that. Let's see if it's symmetric. Yes, it's very, very symmetric. And yeah. Okay. Now I will just take it off from there and depur it. So now this is the workpiece at the moment. I have depured it and yeah. Now it's time to put something into this hole here. Yeah, and it will be a 16mm round bar. Hopefully I can get it into there. Yes, I can get it into there. Let's put it somewhere like there. Let's see about the speed. It's well, a little bit little. 100, 2000, 1200, I mean. I will now face it. Face it. This is again my favorite insert, it's VNMG. So just feeding manually here. And I believe it is done in one go. Yeah. The surface finish is, well, not too bad. We don't need this anymore. So now about the drill for M10 thread. The drill would be 8.5mm. Okay, let's take an 8.5mm drill. I have here an index. Yeah, 8.5mm drill. First I will use the stop drill. I don't need this anymore. This goes to my stock. This goes that way into there now.
So now there will be an M12 thread. So the outer diameter should be 12 millimeters. I will turn, it will be like 30 millimeters long, and yeah, so it's just simple turning it down to the required diameter, which is 12 millimeters. So yeah, and I'm running this at 1200 revolutions per minute and medium speed of feed. Oh, that's the zero. Let's take, well, 1 millimeter. It should be quite feasible for this one. Okay, now I will clean it up properly at this end, the outside and inside the threads. I will also clean these parts because I will glue them here, like this. They will be glued on place. Okay, last step, glue. Well, I have here protection for my lathe. This is Loctite 648 glue, and I will put quite liberally it here. Also in the inside, and I see that it's everywhere. And then I glue this one too. This is so-called permanent lock glue, so it will lock it permanently. And now I tighten it really tight. Yeah, there you are. Now we just wait for the glue to cure. Well, now we have two of these, the old and the new one. Let's see. The other one is the old, the other one is the new. Yeah. This is the new and it's more like the original. This is the old one, which is not like the original. The other end is very similar. This has a chamfer, this doesn't have. And well, you decide which one is better. But there is one thing, really big difference is this hex hole here. And yeah, let's see how it works. So you first put it in here. It rotates quite nicely. Then you put here a thing, put it like that, and then you can take your Allen wrench and tighten it with that. But you can also tighten it with this one, which I have been using a lot. This you can put a little bit more torque into that, and there you are. Okay. Then when you want to take it out, you just, oh, well, this is a little bit tight, but it works. Yeah. The thread lock, and then in order to get this out from here, you need to knock it a little bit, but just a little bit. I have the original Schaublin, which has been knocked with the ball peen hammer, I believe, and this has mangled. There is a hex in that one, but you cannot use it. It's and it's hardened. So somebody has succeeded in mangling that one. So you cannot put your wrench into there. So maybe I also need to make that one. But this is now ready. Okay. So in the next episode, I think I will try to create a cooperation with Max Grant. I visited him when we were visiting Australia, and he has now promised to answer some Finnish questions. I'm pretty sure there are differences between Australia and Nordic countries like Finland when it comes to hobby machinists. Something like what type of machines we have here, what, how are our flea markets, etc. But that all will be in the next episode. So till then, bye!